Imagine a giant invisible switch controlling Earth's climate. For centuries, it's been stable, but now it's flickering. Scientists warn that if global temperatures rise just a little bit more, we could flip this switch, triggering irreversible changes that spiral out of our control. We're talking about climate tipping points, moments where small changes lead to massive runaway shifts. Is there a point of no return for our planet's climate? Are we safe when we get to the effect of our planet's climate? Well, where are we coming from? Everything is a system. In this grade 9 lesson, we'll explore how Earth's climate acts as a complex system where small changes can have massive, cascading effects leading to what scientists call tipping points. Dr. Anya Sharma, a leading climate scientist at the National Center for Atmospheric Research, explains that climate tipping points are critical thresholds. Beyond these thresholds, a small additional change can trigger a dramatic, often irreversible shift in the entire system. Think of pushing a ball up a hill. A tiny extra nudge can send it tumbling down rapidly. A key example is the culture ice-albedo feedback loop. As global temperature rises and melts ice cover, less sunlight is reflected back to space. This lower albedo effect means Earth absorbs more heat, further accelerating warming and ice melt. Another concern is the permafrost carbon bomb, where thawing permafrost methane release adds more greenhouse gases to the atmosphere. To understand these tipping points, we need to look at the key components of Earth's climate system. Our primary external input is CO2 emissions from human activities. The internal outputs include global temperature, ice cover, the albedo effect, permafrost methane release, sea level, and ocean heat absorption. These components interact in crucial ways, determining the planet's fate. Let's trace how these components connect. CO2 emissions have a positive relationship with global temperature, driving warming. This higher global temperature then has a negative relationship with ice cover, causing it to melt. Less ice cover means a positive relationship with the lower albedo effect, as darker surfaces absorb more heat. This lower albedo effect then has a negative relationship with global temperature, completing the reinforcing ice-albedo loop. Additionally, above a critical threshold, global temperature has a positive relationship with permafrost methane release, which in turn has a positive relationship with global temperature, creating another runaway feedback. All this leads to a positive relationship with sea level rise. Build your climate tipping points model. What if CO2 emissions were reduced by 50% by 2050? Or what if the permafrost threshold is lower than scientists currently estimate? What impact would these changes have on global temperature and sea level? Understanding these systems opens doors to vital careers. Climate scientists and Earth system modelers build computational models and study tipping points. They can earn between $80,000 and $160,000 per year, directly informing international climate policy decisions. Everything is a system. Model it. Build it, simulate it, understand it. Visit ModelIt K12.com.